Hello students. In this video we're going to use the difference of two squares to factorize these expressions. Now if you look at the first expression here, there's a bit of a problem because 2x squared isn't a perfect square and 8 isn't a perfect square. And this is going to teach you a very important lesson about factorizing, which is the first thing you always do when you're factorizing an expression is looking for a common factor. So 2x squared and 8 has the common factor of 2. So 2 outside of x squared take 4. And if you look at what's left in the brackets, we now do have a perfect square. So this is x squared, that's 2 squared, and from the previous video we can rewrite that as x plus 2, x take 2. Okay, let's have a look at this one down here. Okay, again, 5 isn't a perfect square, 5h squared isn't a perfect square, but I can take out a common factor of 5, which is 1 minus h squared. What's left in the brackets is a perfect square. That's 1 squared and h squared. So that can be factorized as 1 plus h, 1 take h. So I'd like you to have a go at these two questions here and start by taking out a common factor. Okay, let's see how you went. So 27y squared minus 12, we always look for a common factor first. Well, the common factor here is 3. That leaves behind 9y squared take 4. Now, if you look at the expression in the brackets, that's 3y all squared. That's 2 squared. So we do have a difference of squares, and that can be factorized to 3y plus 2 and 3y minus 2. Okay, looking at the last question, once again, we can't find the difference of two squares yet. But if we first take out the common factor of 2, we end up with 2 outside of 1 take 9k squared. Well, that's 1 squared, that's 3k all squared, and this factorizes to be 1 plus 3k times 1 minus 3k. So, very important lesson from this page here is the first thing you do when you're factorizing an algebraic expression is to take out any common factors.